Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is fixing two swap nodes of a binary search tree. So the problem is pretty big and it is of hard difficulty, but we are going to discuss a very simple approach to this particular problem. It's just that we have to make some key observations that will help us to reduce this problem into a smaller subproblem. So let us quickly start with the question. So this particular question says that we have been given a binary search tree and we have to there is some problem in the tree. Exactly two nodes have been swapped, right? So there will be one pair of nodes whose values have been swapped and we have to figure out which nodes is it, fix them and return the root of the binary search tree. So let me just show you with an example. So this would be the example that we'll be using. Now this particular this particular test case has these values, right? So in this particular test case, if you see that 20 is not in its right place. Why? Because it is in the left subtree of 10 and its value should be less than 10 or equal to 10, let us say, right? But 20 is certainly greater than 10, so it is not at its correct position. Similarly, we have 8 here. Now 8 is in the right subtree of 10, so it should be greater than 10, but this value is not greater than 10. So these two values are not at their correct position. Now a fix to this problem would be moving 8 here and moving 20 here. Right. So this would solve all of our problems. There is one more very important thing given in the question, that we cannot change the structure of the tree. By structure of the tree, we mean that the original binary search tree is like this, so the resulting binary search tree should also have their nodes arranged like this, right? It should follow the same pattern and the value should be in correct order. So this is our question, and at the end we can just return the root. So one very important observation, the most important observation in this particular question is that the in order traversal of a binary search tree, if we do in order traversal, it is always sorted. These three are the keywords. If you do in order traversal in a binary search tree, it is always in sorted order. Now let us perform in order traversal in our original input question. So it was 20 here and 8 here. For in order traversal, let us go to the left part and then again left part. So first of all we will have 2, then we'll have the root, we'll go to 5, then we can go to 20, and then again we go back to 10, and then we at the end we go to 8. So this would be the in order traversal of our binary search tree. So like we have an array kind of thing, and this array we know should be sorted in order for the binary search tree to be correct, or for it to be a valid binary search tree. We see that this particular array is not sorted, right? So we need to fix it. Now how do we fix it? We know that the values should be, that the ith value should be greater than or equal to the I minus 1th value for it to be sorted, right? So here this condition is satisfied. 5 is greater than 2. Now 20 is greater than 5, but 10 is not greater than 20, right? So this is an issue. Now we can assume that the first value that is wrong is 20 and the second value that is wrong is 10, right? Now we again move further. We see that 8 is smaller than 10, so we can update the second value to be 8. That this is the particular node that is incorrect, right? And at the end we have first and second, we can just swap them. Now a very valid question is why we are updating the second value, right? There is a reason to it, and the reason is in the question itself. So the question says that the given input will form a BST except for 2 nodes that will be wrong. So we, from this particular statement, we can understand that there are exactly 2 nodes that are at wrong positions, right? So for example, if we have some elements A, B, C, D and E, now if this and this is at the wrong position, the middle elements that are between them are assumed to be in sorted order. They will always form the sorted order. Why? Because there are exactly two elements that are at the wrong positions. Right? So we can always update the second node which is wrong to be the last variable or the last node which is wrong. Right? In the whole array, wherever we find the wrong positions, the first node that is wrong would be the first position at which the array is wrong, and the last position would always be the last, or the second position would always be the last position at which this is wrong, that a of I should be greater than a of I minus 1. Wherever this condition is satisfied, the last position at which this condition is satisfied will form our second. Right? Why? Because all of the middle elements that are in between, we assume that they must be in correct order, because we have been given in the question itself that there are exactly two nodes which differ from their positions. Right? So once we know that which two are wrong, the first and the second nodes which are wrong, that this is wrong and this is wrong, we can easily interchange their values. Right? So this would be the solution for this particular problem. Let me repeat it again. So the problem says that there are exactly two nodes. The two important observations that you need to take away. The first one is in order is sorted. When we know that in order is sorted, the problem is reduced that we have been given an array. So this is no longer a problem of a binary search tree. It has been reduced to a problem where we have been given an array and we have to there are two elements which are not at the correct positions, and we have to swap their positions to make the array in sorted order. Right? So this has been reduced to a question of an array. Now the first observation is that in order is sorted. The second important observation is exactly two nodes are at incorrect position. We can say this incorrect position. Right. So these are the very two important observations that you need to like observe from the question. Now we know these two things. So the first thing is we form an array where all the elements are stored in order traversal. We just check which of the positions are there which are not with respect to the increasing order of the array. For example, this particular position, these two form a pair where it is not satisfying the property of a sorted array, and these two elements are there which is not satisfying the property of a sorted array. Now we again know that there are exactly two elements from which are at not their correct position. So we can assume that if there are multiple elements, for example, these are the multiple elements which are not at their correct positions, we find in our while traversing through the array. So we assume that these between elements, no matter how many of them are there, we assume that these are already in sorted order, and the only ones that we need to change are the corner ones. So we take the first one, we take the second one, we swap their positions and print our final answer. So let me show you the code for it now. So we have been given this particular function, and we create a vector of nodes which is called in order. So it will store the in order traversal of the binary search tree. Now I call the traverse function. But the traverse function is pretty simple and standard. If the current node is null, I just return. Otherwise, I go to the left subtree. After coming back from the left subtree, I push the current node into my in order traversal vector, and after that I go to the right subtree. So this thing is pretty standard. Now after that, I initialize two variables. Both of them are of the node type. The first one is called first, second one is called second, and both of them are initialized with null pointer. I just traverse through the whole array starting from position 1, and if I just check this simple condition whether the current element is less than the previous element or not. If it is less than the previous element, then I need to update the value of first and second. If first is null pointer, that is we have not encountered our first element yet, then we update the first element. Otherwise, we are just update the second element. So why we are doing this? Because for the first element, we need to find the first position where this condition is not satisfied. And for the second element, we need to find the last position where this condition is not satisfied. So we just constantly update the value of the second. Now at the end, after coming out from this loop, we just swap the first and the second. We don't actually swap the nodes, we just swap their data, right? So their values are swapped. Now at the end we can just return the root. So this was the solution of today's problem. So this was like, it is a hard problem, but a few observations will help you solve this problem easily. And I hope that you guys were able to understand the solution. If you guys were able to understand this, you can show your appreciation by clicking the like button and subscribing to this channel. And of course, you can share these videos with your friends. It will help them a lot. So till the next video drops, keep coding, stay safe. Bye bye.